So today's example, the third one which I have taken, it is till the second position. It is similar to the first example, whatever we have discussed. Just read out the question. A square pyramid having 35 millimeter base side and 65 millimeter axis length rests on HP and one of its edges of base. Draw the projection of the pyramid when the axis is inclined to HP at 45 degree and VP at 30 degree. So it is very much similar to the first example, wherein the first example, so the edge which is resting on HP, it is inclined at 30 degree or some inclination with respect to VP as given. Here, the axis itself is inclined at the 30 degree with respect to VP. That is the only difference. So here also, as usual, so we are looking at the question, the square pyramid. So having 35 millimeter as a base side and axis height is 65 millimeter, resting on one of his edges on rests on HP and one of his base edges. So this is your base edge. So you draw the square such that square of 35 millimeter in the top view, such that any one of the edge should come right side of you. So here, so 35 millimeter square you can draw. You can name it ABCD, whichever fashion you want. And to find out the center of the square, draw the diagonals. And I'll call the base point as the center as the O1 and axis at the vertex point as the O. Okay, and for all the pyramids, you remember that from the center of all the pyramid in the top view, true shape diagram, all the corners should be joined and she should be highlighted. It's a visible edge only. Okay, in the top view, when you see from the top, you can see here, it look like the base will look like a square and the slant edges will look like a diagonals. So that's why the slant edges also will look like a visible edge. Next, after this, coming to the front view, you draw the vertical projectors from all the 3 points like this. So already we have done this in the first example. Draw the vertical projectors, and from the center you take 65 millimeter. This is the axis of your the square pyramid. Mark it on that. You call that as the O dash. From here you draw a line to these the end point, and you are looking from here from the front side. A and D points you can see, you cannot see B and C. That's why the B dash and C dash should be written within the bracket. And O1 point is the base point. Here it is. So even in the front view or top view, you cannot see that. That's why. So it is written within the bracket. So this completes your the two shape diagram, that is front view and top view. Next, coming to the next this step, what he has given. So he has given the axis of the pyramid is inclined at 45 degree to HP. He has given. So in the last class, the same thing we have discussed. The base and the axis of the pyramid is mutually perpendicular to each other. Correct? So this is your axis. Axis is making an angle of 45 degree in the sense. So the base and axis are mutually perpendicular to each other. The base also should have the 45 degree. So that's why what I will do, I'll take right side on the XY line A1 point and I'll draw a 45 degree line, that is base inclination left side like this, base inclination. Okay, after drawing this base inclination, I'll redraw this previous front view such that this isosceles triangle base, this base should exactly rest on this 45 degree line. So without changing its shape and size and all the points, I need to redraw it. Okay, how to redraw it? First you are taking this D dash and C dash point here. So you take this length, the base as your length, that is 35 millimeter. This as the center, you cut this 45 degree line. Okay, and you call this corresponding points the A dash and B dash, and take from here to here or here to any one center point, and from here you cut it, you will get O1 the point also. And from this O1, what you can do, you draw a 90 degree line to this base or perpendicular line to this base. So on this perpendicular line, you take 65 millimeter is the axis side, correct? You take 65 millimeter and cut it here. So you'll get this O dash also. After getting all the points, you join it. So you're going to get this, the isosceles triangle, and this, the base is inclined at 45 degree. Because the axis inclination is given here. So my convenient, I have taken the base inclination. That's why you extend this axis line till it meets the XY line. Now you show the axis inclination, it is 45 degree. So that's all. So now to draw the front view, so to draw the top view, draw the vertical projector from all the front view like this. 1, 2, 3, and 4. From here also you should draw the vertical projector. So not shown here. And then draw the horizontal projectors from the previous top view also. 3 points will going to get. Now coincide the points. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. O1, the base point of the axis is here, and O1 is here, this is O1. O, the apex point is here, and O dash is here, so this is your O. So here, so after getting these points, so we need to join these points properly, and we should see to that the visible edges and hidden edges also. So you are looking from here, coming to the base first, A to B I can see, yes, B to C as well as A to D also I can see, it becomes outermost boundary line. And coming to the C to D, the base edge which is resting on HP, you are looking from top. So you cannot see the C to D edge. That's why the base edge C to D you cannot see. And coming to the slant edges A to B and A to O and B to O, you can see A to O, B to O, and C to O and D to O also you can see, because it becomes outermost boundary edges. So it is exactly like this. The first position you have written the front view and top view. Second position you have tilted it like this. So when you are looking from here, 1, 2, 3 base edges you can see. You cannot see this edge when you are looking from the top. So that's why only CD is hidden edge. At the end, you join this O1 to O, so that becomes your axis line. You can represent this axis. Okay, fine. Next, to draw the next position, see, as given the axis is also inclined at 30 degree to VP as given, correct? So what you have to do is the inclination, whatever he has given, it is true inclination only. Okay, the true inclination always, what we have discussed, the true length only should come on this true inclination. You take any one of the point on the XY line right side and draw 45 degree line in whichever the direction you want, that is 30 degree line he has given, correct? You draw a 30 degree line from any one of the point of the X. Here, why I have taken one more horizontal line. Here itself, if I take means it may, okay, cross this, because in this each and every view should be distinctly, should draw it. I should not overlap on the other view. So that's why if I take 30 degree from XY line, or if I draw any one horizontal line below this, if I take 30 degree from there, it is one and the same. Okay, it doesn't make any difference. So I'll take 30 degree from XY line, I'll draw a 30 degree line, or below that one horizontal line you can draw, and from there you can draw 30 degree line, the axis whatever he has given. I'll take any one of the point on that the 30 degree line, I'll call that as the apex point O. Okay, after that what I'll do, so I'll take the true length of the axis. What is the true length of the axis? 65 millimeter. That's what I've shown here. The true length of the axis is 65 millimeter. I'll take this O as the center, and this 30 degree line I'll cut an arc. Okay, after cutting an arc, you draw the horizontal line. So this is the locus of the true length. Draw the horizontal line like this. After drawing this, now you take the apparent length of the axis O1 to O. Okay, so you take this O to O1, this distance, with the same center O, you cut this locus line, horizontal line which you have drawn. Now you call this point as the O1 point. Join this O to O1. So this is your actual axis, and if you want, you can extend this the line towards XY line. So whatever the inclination that you are getting it, that is your apparent inclination beta. Once you get this O and O1, these 2 points, now what you have to do, you have to redraw this previous top view such that this O1 should coincide with this O and O1. Like that you should draw it. How to draw it? So O to O1 already it is here, correct? O to O1 already it is here. So O1 to this till here the hidden edge, as well as this O1 to this edge. Okay, so AB it is same. You take either this or this distance from O1. Okay, you cut it on either side. You extend this line also here. Okay, so you will going to get these 2 points. From these 2 points, you draw the perpendicular line from this point as well as this point. After drawing a perpendicular line from here to C and from here to D, it is saying from this point to B and from this point to A, it is saying you take any one of the distance from here, you cut it on either side. From this point, you cut it on either side. You're going to get ABCD. Okay. After getting this ABCD as well as O1 and O without changing anything here, so visible edges as well as the hidden edges, you redraw it here. Okay. So this completes your the top view, final position top view. After this, to get the front view, you have to keep on draw the vertical projectors from the top view like this. How many points you're going to get? 1, 2, 3, 4, 5, 6, 7 points you're going to get. Okay. 4 plus 6 points you're going to get. Here, draw the horizontal projector. 1, 2, 3, 4 points you're going to get. Now go inside the points. There is A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C is here and C dash is here, this is C dash. D is here, D dash is here, this is D dash. O1 is here, the base axis point. O1 dash is here, this is O1 dash. O is here, apex point, and O dash is here, this is O dash. After the getting all these points, you are looking from here. For the front view, you are looking from here. The base you can see. For all the final position, apex you are writing towards XY line, and the base you are writing away, drawing away from the your XY line. Then automatically the base of the entire pyramid you can see. That's why ABCD is seen. It is like this. You have tilted in the first view. Now tilting it like this towards XY. That's why the base of the pyramid you can see in all the cases. And coming to the slant edges, 1, 2, 3 slant edge you can see. You cannot see this slant edge which is behind you. That means the slant edges A to O, D to O, and B to O you can see. The slant edge C to O you cannot see because it is behind you. You are looking from here. That's why C dash to O dash you make it hidden edge. So this is how you have to analyze, and you have to draw the visible edge as well as the hidden edges. And at the end, axis line O1 to O dash, you draw an axis line representation. So if you do this, this completes your the projection of the solids with this the combination which is the given. Okay. So after this, so almost 3 examples we have discussed. Next we will discuss the pentagon pyramid. Pentagon pyramid will discuss. So similar to the square pyramid, pentagon pyramid will have a 5 the regular this side. It has got a pentagon the base, the pentagon pyramid, and it is bounded by 5 isosceles slant triangular faces, and it has got apex here. Okay, so this is your the pentagon pyramid. So let me see. So what is the question is given in the pentagon pyramid? A regular pentagon pyramid of side, base side 30 millimeter and axis height 60 millimeter. The base side is 30 millimeter, axis height is 60 millimeter. Rests on edge of the base. Rests on edge of the base. The base is tilted until its axis apex is 50 millimeter above the level of the edge of the base on which it rests. Okay. Draw the projection of the pyramid when the edge on which it rests is parallel to VP and apex of the pyramid points towards the VP. Just read out this question once or twice, then you'll understand what exactly is looking for. He says regular pentagon pyramid is there, and he says it is resting on one of his base edge on HP. Whether he gives HP or not, okay, it is resting on HP only. You write the pentagon such that the base edge should come right side of you. So that means you draw a XY line and draw a pentagon such that the side of the pentagon should come right side of you like this. Draw the pentagon. After drawing a pentagon of 30 millimeter, you know how to draw the pentagon. You name it all the 5 corners, and then how to find out the center for the pentagon. So already this also we have discussed in the class. So how to do it? You bisect any 2 side. For example, D to C. How to bisect this D to C? Take more than half curve, cut it here, and cut it here. Okay, you will get one intersection point. Similarly, D to E also you do the same thing. Take more than half, cut an arc, and cut an arc here. From this intersection, you join it to this opposite corner. From this intersection, you join it to opposite this corner. So wherever these two the lines intersect, you call that as the center of your the pentagon. This how you have to find out the center for the pentagon. After finding out the center, from the center you join all the corners with a thick line, because in the front view, the hexagon pyramid, the pentagon pyramid, to see from the top view, the base look like a pentagon, and the slant edges will look like a diagonals. Okay, so that's why. So these lines also are visible lines only. This completes your top view. And coming to the front view, draw the vertical projectors from all the points, from here, from the center, from this point. And from the center, this is the axis line, correct? From the center, you take 60 millimeter. This is the representation how we have to represent the axis line. Should be light in all the views, and this is how we have to represent the axis line. Okay, so take 60 millimeter, cut on this vertical line and call that as the apex point O dash. Now you join a line with respect to apex to all the corner. Okay, so this completes your, it look like a triangle. Okay, it look like a triangle, and coming to the edges, you are looking from the front side. A, E, D you can see, you cannot see B and C because it is behind you. So that's why C and B point should be within the bracket. Okay, and O1 is the base point of the axis, and O is the your apex point. So this completes your the front and top of the pentagon pyramid. Next, what he has given? So he has given, so the question clearly has given the base is tilted until its apex is 50 millimeter above the level of the edge from the base. So it is like this. So you have taken the edge on your right side. So apex is tilted such that from the base it should be 50 millimeter distance. This distance is 50 millimeter. So now this is the initial position. The apex is so tilted in such a way that the distance with respect to apex and the base, this perpendicular distance is 50 millimeter. To do this, how you have to draw this? So let me explain the next slide. You on the xy line you draw 50 millimeter line and draw one horizontal line like this. Just all of observe the cursor. You take 50 millimeter above xy line, draw one horizontal line. After doing this, so that means your apex point should come on this particular 50 millimeter line. After that, what I will do, I will take any one of the point right side here, and I will call it, because it is resting on base. So A dash and B dash I will call this edge. Okay. After this, I will take this A dash point to the O dash, and I'll take the distance. This as the center. I'll cut this 50 millimeter line. I'll cut this 50 millimeter line, and I'll call it as the O dash, because this is the apex which has to be tilted in such a way that it is 50 millimeter above the base, correct? So I got this A dash B dash point as well as the O dash point. Now I need to get this point. How to get this? From A dash to D dash. So this distance you take and cut an arc somewhere, some arc to some length, you cut it here. Similarly, O dash to D dash length you take with the help of your compass. This is the center, you cut this arc. Wherever these two arcs intersect, from that point you join it to this line as the A dash as well as this O dash. Then this outer triangle is ready. Now after once you get the outer triangle, so in the same line you will get the C dash as well as O1. So D dash to E dash C dash distance you take on this line, mark it, you call it as E dash and C dash. And A dash to this O1 dash, you take the distance, cut it here. So all the corresponding points also you shift it here. This is your the front view as per the information which he has given. What he has given? So the apex is tilted in such a way that it is 50 millimeter above the base he has given. So this is what we have the drawn the front view for this. So after this, the top view, you know how to draw it. Draw vertical projectors from all the points like this, and draw the horizontal projectors also from all the points from the top view. 5 points you're going to get. Coincide the points. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is E. And base center point O1 is here, O1 dash is here, this is O1. Apex point O is here, O dash is here, this is O. Like this, all the points here. Now you have to see from the top to draw the hidden as well as the visible edges. You are looking from here. If you are looking from here, so the nearest the base edges are D to C and D to U. You can see D to C and D to E. So definitely A to B edge which is resting on HP I cannot see. So A to B is done as well as A to C as well as the A to E as well as B to C also you cannot see. It is exactly it is like this. You have tilted it like this, correct? You have tilted it like this. So you are looking from here. You are looking from here means only these two edges I can see, the base edges. Remaining these three edges I cannot see. That's why I made it hidden edges. And coming to the your slant edges, after completion of your the base edge, all the corners of the base should be joined to your vertex or the apex. So you are looking from the top. D to O you can see as continuous line I can write. E to O and C2 also we can see it becomes outermost boundary edge. What about this A2O and B2O? Can you see this? You are looking from here, from the top. So you cannot see these two slant edges, A2O and B2O. That's why A2O and B2O is also hidden edges. So this completes, and here axis line O to O1. So I cannot represent it, but the axis here because already visible edge is here. Even if you draw an axis line here, I cannot see that because already visible edge is here. So this completes your the top view, second position. Now coming to the third position, what he has given. So in the third position, he has not given any inclination here. Okay. So he says the base edge, it is resting. Which is the base edge which is resting? AB. Correct? He says it is parallel to VP. When it will become parallel to VP? If it is parallel to XY line, it becomes parallel to VP. That's why. So you have to redraw this the previous top view such that the resting edge of pentagon base, that is AB, should come parallel to XY line. Then that completes, that fulfill the requirement whatever he has given. How to do this? First you take on horizontal line some distance. This distance should be greater than this. Okay, distance. So you take below XY line, you take on horizontal line. On that horizontal line, I'll take any of the point. I'll call that as the A. On that horizontal line, A to B distance I'll take from A. I'll cut it here. AB point I got. Okay. After getting this AB point, so you know how to redraw the pentagon in the projection of plane surface. You have many examples. You have discussed either the arc method or box method, whatever the method you want, you can redraw it. A to B I got here on this horizontal line. So that means it is parallel to XY line, means parallel to VP. After that, what you can do it? So after getting A to B, so A to B between this, so the center point I'll take, and this center point I'll draw a perpendicular line. I'll mark this from A to here. I'll take the distance from A to, I'll cut it here and I'll draw a perpendicular line or 90-degree line here. Okay. After drawing a 90-degree line there, so from here I'll take from this point to O, apex point I'll get, that is O I'll get. Similarly from this point I'll take this distance and cut it here. I'll get the O1, the base axis point. Similarly from this point I'll take this distance and I'll cut it from here, that perpendicular line. I'll get the point D also. So after getting this, so I need to get C as well as E also. From here either you can take this distance and cut an arc on either side, arc method. And then after that from here to here and here to here distance you take from here, and from here you cut it, the intersection point C and E you can use it. Or else from D to this distance you can take, draw a perpendicular line to this, that is horizontal line, because it's a vertical line. And that you take this distance, same on either side, you cut it on either side. So whichever the way you want, you can redraw it. So the base is ready now. So and apex point is also ready here. Okay. Apex point O is also here. Now we need to join all the corners to the apex. That completes your, without changing the hidden edges and visible edges, you need to redraw here. So redrawing, so this completes your the final position top view. After this, so what you have to do, draw the vertical projectors from all the points of the top view. 1 2 3 4 5 points you'll get, and draw the horizontal projectors also like this. Okay, coincide the points. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is E. And O1 is here, O1 dash is here, this is O1 dash. O is here, O dash is here, this is O dash. So all the points are marked here, and now you are looking from here to get the front view. The complete, because base is towards you, the complete base you can see. So base, which is your base, A, B, C, D, E, you can mark it as visible edge, A dash, B dash, C dash, and E dash. After that, coming to your the slant edges. Slant edges. So you are looking from here for the front view. So you are just observe, because you are looking from here. D to O you can see is very nearer to you, visible edge. C to O as well as E to O also you can see it becomes outermost boundary line. Can you see this B to O and A to O? That we cannot see. So that's why these two are hidden edges. It is like this. The first position. So I have tilted it like this. First position, second position, I have tilted it like this. Now I made it parallel like this. The base is parallel to X. Now the complete base you can see. The slant edge 1, 2, 3 you can see. You cannot see these two slant edges. That is what I have shown here. So this the completes your the projection of the orthographic projection of your pentagon pyramid in this particular case. Okay, this here the angle is not given both, but he has given say, some other details so that we can able to complete the orthographic projection in all the three positions. So after this, so one more example we discuss pentagon edge condition only we'll discuss. So edge condition. So here axis inclination is given. What is given? A pentagon pyramid of almost 25 millimeters side of base, 60 millimeter axis length, rests on HP on one of its edges of base. Excuse me. Draw the projections of the pyramid when the axis excuse me, inclined to HP at 40 degree and VP at 30 degree. Here the inclination whatever he has given, both are the true inclinations only. So here, so for the final position we have to take the locus. Okay, so first let me draw the pentagon such that the base edge of the pentagon should come right side of us. That is what I have done here. You know how to draw the pentagon. Draw a pentagon, name all the corners, and bisect any two edges. Draw a line from that intersection to the opposite corner. You're going to get a center. From that center, a join to all the corners. So your top view is ready. Okay, the base of your pentagon look like a pentagon and the slant edges will look like a line. So that's what we have done. And then to draw the front view, you draw the vertical projectors like this from all the points, and then from this axis point, so this is the axis line, correct? Draw a line which is equal to 60 millimeter. Cut 60 millimeter. That is your apex. Once you get the apex, join from apex to all the corners. The three, that is all the points. Okay, and you are looking from here A, B, C. You can see, you cannot see D and E. That is what D dash and D dash are put within the bracket. That's all. Okay, so you can complete this front view and top view very easily. The first position. Second position, he has given the axis is inclined at how much? 50 degree, 40 degree, sorry, 40 degree with respect to HP. So the base, the axis is 40 degree. How much the base? Because axis and base are mutually perpendicular to each other. If the axis is 40, the base 90 minus 40. How much? I should take 50 degrees. So what I should do? I'll take any one of the point right side of the XY line. I'll draw a 50-degree line on the left side like this. Okay, what I should do now? I should redraw the previous front view such that the base of this triangle should exactly lies coincide on this 50-degree base inclination line. How to redraw this? So this point I have taken it as A dash and E dash. Okay, I'll take this distance A dash to C dash. I'll take this distance, this as the center. I'll cut this 50-degree line. I'll get C dash. Similarly, you take this distance, cut it here, transfer this point, and O1 distance also you take from this point, and from here cut it. You transfer all the points without changing anything. Okay. After that, from the axis line, you draw a perpendicular line or 90-degree line to this base. Okay, and this perpendicular line, the axis height is 60 millimeter. You take 60 millimeter and cut it, you will going to get the apex point O dash. Now you join all the points so without changing anything, the shape and size, everything you should redraw it here. So this completes your the front view. And extend this axis and measure the axis. So definitely, if this is the base inclination 50 I have taken, so 90 minus 50, it has to be 40. So this is what the 40-degree of the axis he has given. So you have to mention this axis, okay, with respect to XY line. So after this, the top view is very easy. Just you have to draw the vertical projector from all the points and horizontal projectors from this top view, previous top view. Coincide the points now. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is C. And the base axis point O1 is here and O1 dash is here, this is O1. Apex point O is here and O dash is here, this is O. So the complete, so all the points we got. Now we are looking from here, from the top we are looking, okay, C2, B and C2, D you can see. That's why this becomes outermost boundary line. We can draw it with the visible edge. And here A to E, which is resting on HP, you are looking from the top side. You cannot see that. A to E is hidden edges. Similarly, A to B as well as D to E also you cannot see. It is exactly similar to the previous case. See, you have tilted it like this, correct? The base edge only 1, 2. These two base edge you can see. You cannot see the base edge which is resting and other two base edges you cannot see. The three base edges are hidden edges. 1, 2 and 3. Now coming to the slant edges, C2O. So you are looking from here, you can see C2O, you can see. B2O and D2O also you can see, it becomes outermost boundary line. And A2O and E2O you cannot see because it is behind you. So that's why E2O and A2O slanted is also hidden edge. And axis line, just the points I have mentioned here, I cannot represent because already visible edge is there. Okay. So this completes your top view. Next, coming to the next position top view, he has given the axis is also inclined at 30 degree to VP. This inclination is the true inclination. If the true inclination is given, the true length of the axis first we have to take, and we need to find out the apparent inclination of the axis. Okay, so we have done this for 3 examples. You take any one of the point of the XY line, the space is not sufficient in your sheet or sketchbook. Below that, draw an horizontal line. From there, you take 30 degree line. And that 30 degree line, you take the apex point first, O. Now you take the true length of the axis. The true length is actual length of the axis, that is 60 millimeter. With this O as the center, you cut this true length of the axis. Okay. After getting this true length of the axis, wherever it cuts, you draw the locus line, that is horizontal line you draw, that is the locus of the true length. Okay. After drawing a locus line, what you have to do is, now you take the apparent length of the axis O2, O1 from the previous top view. Okay. You take this length with the same center O, you cut this horizontal line, that is locus line, you cut it. Now you call that as the O1, join this. O and O1 is ready. So once you get O and O1, now you have to redraw this, the top view such that this O1 and O should exactly coincide with this point. Okay. So how to redraw this? So many cases we have discussed. So O and O1 you have here, correct? You extend this line till it meets the XY line also, so that you can draw this apparent inclination almost 41 degree, you will get that is beta. You extend this line on both the side. So O and O1 you know. From O1 you take this distance till this dotted line, and from O1 to C distance you take and cut it on either side. So C you will going to get here. So wherever this dotted line you are cutting here, from here you take from here to E distance, and from this point to A distance, cut it on either side, you will going to get A to E. Okay. After that, to get the B and D, you can use arc method, or else this distance C to this line you can take distance. You can draw a perpendicular line to that. After that, you can take this distance from here to here and you can cut it. So all the points you can get. So without changing anything, after getting all the points, you redraw it here, including the hidden edges, the visible edges, everything. So this completes your the top view. Okay. After this, so you have to draw the front view. How to draw this? So draw the vertical projector from all the points of your the top view, and draw the horizontal projectors from all the points of your front view like this. So after this, coincide the points. Where is A? A is here, A dash is here, this is A dash. B is here, B dash is here. Where is B dash? So this is B dash. C is here, C dash is here. So this is C dash. D is here, D dash is here, this is D dash. E is here, E dash is here, this is E dash. O1 is here, O1 dash is here. So this is O1 dash. Apex point O is here, O dash is here, this is O dash. All the points you are getting, since so I'm tilting it the apex towards the XY line and the base towards you. The complete base you can see in all the cases. This is true. So from here, looking from here, the complete base you can see A, B, C, D, E, A dash, B dash, C dash, and D dash and E dash. You can make it visible edge. The base completely you can see. And coming to the slant edges. So we are looking from here, B to O you can see. So you can draw a, this is also a visible edge. Thick line you have to draw. So you can see B to O, visible edge. C to O also you can see, outermost boundary line. And A to O also you can see it become outermost boundary line. I cannot draw a dotted line here. So which are all the two edges I cannot see. You are looking from here, D to O I cannot see, and as well as E to O I cannot see. You are looking from here. So that's why D to O as well as E to O are hidden edge. It is like this. So you have tilted it like this, and now we have tilted it like this. Correct? The complete base you can see. The slant edges 1, 2, 3 you can see. The remaining 2 slant edges I cannot see. So this completes your projection, and at the end axis line you can draw from this O dash to O1 dash. So axis line representation you have to show it here. Okay. So today 3 examples we have discussed. You completed this today. So Monday, so 3 or 4 examples will work out. So Monday, so hexagon also will discuss. One more example with pentagon we will discuss, and 2 or 3 examples in hexagon pyramid will discuss. And then afterwards some special cases in the pyramids we will discuss. After completion of this, we'll go to the prism. Okay.